All right, guys, so there's one more thing that I want to add to your acid-base notes that I didn't add in your Chapter 4 PowerPoint. Now, we last stopped with the neutralization reactions. For the acid-base neutralization reactions, we know that when we react an acid with a base, then we will produce water and we will produce salt. But there's one exception when it comes to acid-base reactions, so just be a little cautious of this, okay? And that is, you want to look for keywords. So one keyword or one key phrase is excess base, or you may see something that says equal concentration of acids and bases, or equal moles of acids and bases. Okay, well, what's the difference? When you see the phrase excess base, so let's just say, for example, sulfuric acid is reacted with excess sodium hydroxide. Sulfuric acid is reacted with excess sodium hydroxide. Then in this case, your products are going to be exactly how you would have done them before. I had SO4 goes with sodium. Hydrogen will go with hydroxide. So I made sodium sulfate and water. So if I see excess base, everything stays the same in my acid-base neutralization reaction. You would have written it just how you would have before. The tricky one is if I see this phrase that says an equal number of moles of sulfuric acid and sodium hydroxide react, or equal concentrations of sulfuric acid and sodium hydroxide react. If you see that, then in this case, what will end up happening is that if I look at my products, I before said that I would have made sodium sulfate, but in this case, I made sodium hydrogen sulfate. So if I mix an equal number of moles or an equal concentration of acid and base together, then what ends up happening is not all of that hydrogen from the acid is going to react with the OH from the base. So because of that, I have this hydrogen that's going to be carried over in the salt. That will happen every time when I see this equal number of acid and base, or equal concentrations of acids and bases, or equal moles of acids and bases, okay? So the only one that will be different is if you see this phrase right here, and I can see that my reactants were the same. The only difference is that I'm going to have some hydrogen that's going to be left over in the salt, because not all of this hydrogen is going to come over here and react with that hydroxide. I need excess base for it to go to full completion for that salt and then that amount of water. And I can see too that because of this hydrogen sulfate here, my coefficients changed as well for that balancing. So as long as you write your products first, then you can balance. So balancing will look a little different as well. Okay, so we said that our next thing was going to be the gas-forming reactions. So let's do our gas-forming reactions now. For gas-forming reactions, which I actually think we're a little too far, let's go to... And I still went too far. There we go. Okay, so gas-forming reactions. Some metathesis reactions do not give a product that is expected. So sometimes our double replacement reactions, we may assume that we're going to make just two products, but we actually are going to also create some type of gaseous product in these specific types of reactions. There are 4 of them that we're going to need to know. We're going to have to memorize these gas-forming reactions. So there's a lot of reactions, guys, that we're going to kind of have to memorize, get them down, but we're going to practice, practice, practice. Okay, so in this reaction, we have calcium carbonate reacting with hydrochloric acid. Now before, we would have just said, I would have produced calcium chloride and hydrogen carbonate. But in this specific reaction, or specifically when I have any type of carbonate, then it's going to give me carbon dioxide and water. So anytime, and let's write this down somewhere in our notes, okay? Any carbonate plus any acid. Any carbonate plus any acid, let's write this. Oh, down here. Any carbonate, and that'd be CO3 with that 2- charge. Any carbonate with any acid, will produce salt, water, and carbon dioxide, always. So anytime I have any carbonate reacting with any acid, and it has to be carbonate reacting with acid. So any carbonate reacting with any acid will always produce salt, water, and carbon dioxide. Salt, water, and CO2. Okay, let's go back to our PowerPoint. And again, I see that here. I have calcium carbonate, so here's my carbonate reacting with hydrochloric acid. And when these two react, I get CaCl2, that's my salt. I get CO2, that's my carbon dioxide. And then I get my water, H2O. So that will always be the case, okay? So that's one type of gas-forming reaction. Oh, again, I just wrote out another one for us. So let's say that we have sodium bicarbonate or hydrogen carbonate reacting with hydrobromic acid. So in this case, I'm still going to get my salt, which is sodium bromide. I'm going to get my carbon dioxide, and I'm going to get water. And then just make sure that these are balanced, because this one is definitely not balanced. So any carbonate reacting with an acid, I will always produce salt, CO2, H2O. Okay, next one. Any sulfite. So we know that sulfites are SO3, 2-. Any sulfite that reacts with an acid will produce salt, sulfur dioxide, and water. So let's add that one to our notes. So instead of any carbonate, any sulfite, which is SO3, 2-, that reacts with any acid, will produce salt, water, and sulfur dioxide, SO2. Any sulfite, SO3, with any acid will produce salt, water, and SO2. So I can see that in this reaction here. I have strontium sulfite is reacting with hydroiodic acid. So here's my sulfite reacting with an acid. I'm going to make salt. So I'm going to make Sr and I, so I made strontium iodide, and then I have to make water, and then I have to make sulfur dioxide. Here's my sulfur dioxide, here's my water. Okay, our third example of a gas-forming reaction is going to be a sulfide. Specifically, most of the time it's hydrogen sulfide that we're creating. Or it is always hydrogen sulfide that we're creating. So any sulfide, and sulfide is just that periodic elemental ion of sulfur. So let's write this one down. Any sulfide, which is S2-, with any acid, any sulfide with any acid will always form hydrogen sulfide, which is a gas, and salt. Okay, so any sulfide, S2-, with any acid, always is going to form H2S, hydrogen sulfide, which is a gas, and salt. So let's go back and see this one. Okay, I have sodium sulfide is reacting with sulfuric acid. So in this case, I'm going to get sodium is going to go with sulfite. So I see sulfate. Sodium is going to go with sulfate. I see sodium sulfate right here. There's my salt. And then I expect hydrogen sulfide here, H2S. I get that over here. But we need to know that it is a gas. That H2S is a gas. That's super important. Specifically this reaction, or specifically anything that will produce that H2S, that hydrogen sulfide, the reason that this is kind of disgusting is because this is the type of reaction that smells like rotten eggs. So whenever we're dealing with any type of hydrogen sulfide gas, we typically want to do it under the fume hood because you're going to come out really, 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 really stinky if you did it outside of the fume hood. It's completely disgusting. So it smells just really gross. So H2S is that reason for that nasty like egg smell, and it's just so gross. I think it's even worse than rotten eggs. Okay, so far we have 3 types of gas forming reactions. We had any carbonate with acid is going to give us salt, carbon dioxide, and water. We also had then any sulfite with an acid is going to give us salt, sulfur dioxide, and water. Any sulfide with acid is going to give us salt, and then always hydrogen sulfide gas. And the last one, oh, and I didn't add it to this slideshow. So I'll just write it down here. The last one, guys, that I did not write on your PowerPoint, and I apologize, is any ammonium salt. Remember, ammonium would be that NH4 plus. Any ammonium salt plus a strong base, a strong hydroxide, will form any ammonium salt plus any strong hydroxide is going to form water, salt, and ammonia, NH3. So any ammonium salt plus a strong hydroxide, a strong base, will form water, salt, and ammonia. Give you a second to write this, and then we'll do an example of this. Okay, let's do an example, just so we can see what one would look like here. Let's say, for example, we had, let's just do ammonium chloride. Let's do NH4Cl, and we're going to react that with, let's just do sodium hydroxide. Okay, well, this is an ammonium salt because it's an ionic compound, and it has ammonium in it, so NH4Cl plus NaOH. And I know that it will produce 3 things. I know for certain I'm going to make water, so I know I have to produce H2O, liquid aqueous, sorry guys, aqueous. Okay, so NH4Cl plus my strong hydroxide, strong base, NaOH. I have to produce water. I also have to produce ammonia, NH3. And, oh, sorry, again, NH3 is a gas, ammonia gas, okay, NH3 gas. And then the last thing I have to produce is salt. What salt will I be producing? Well, I used up my hydroxide for my water, I've used up my NH4, so if I see here I have Na and Cl, so I must have produced NaCl for my salt. Okay, so is that a balanced reaction? It is not. I need to balance it. So, actually, wait, is it balanced? NH4? No, it is balanced. We're good to go. So already balanced. So an ammonium salt with a strong hydroxide, we will always be producing water, ammonia, and some type of salt. Okay, so that takes us through those gas-forming reactions. Now, I have a worksheet for you that has just a few, some practice problems that I want you to try, and then when you try them, I want you to... I'm trying to think if I want to post these. I will post your answer key for those practice problems that you're going to do on your blog. So I want you to try the practice reactions, bring them to class because I want you to still turn them in. But do your practice reactions. I will also post an answer key after you show them to Mrs. Patel on your blog, so then that way you can look at those as well. Now, tomorrow we're going to focus on our slides 39 through 49, which are redox reactions and then single replacement reactions, okay? So I hope you guys have a really great night, and I will see you so soon. Bye!